Welcome to the lesson on restricted range. Having a small sample size can also impact the results obtained if the data represent a restricted range. Consider we recruited 5 participants and their scores plotted in the scatterplot. In this case, there is a strong, significant positive relationship between the two variables. However, we should consider what might happen if we continued to recruit more participants. We continue to recruit and obtain 17 additional participants, and their scores are added to the scatterplot with the original data. Now, with more participants, no obvious negative or positive pattern can be identified in the data. With the additional participants added, the significant strong positive relationship has become a non-significant relationship. This example illustrates how a restricted range can identify a significant relationship between variables where there is indeed no significant relationship. As a researcher, we would want to ensure that our sample does not represent a restricted range. The opposite may also happen where a restricted range reflects no significant relationship between the two variables when indeed there is a relationship. Consider this example where 8 participants were recruited and the results graphed in the scatterplot. In this case, there is no significant relationship between the two variables. We decide to recruit 12 additional participants and their scores are added to the scatterplot. With the additional participants added, the non-significant relationship has become a significant strong negative relationship between the two variables. These two examples demonstrate the impact of having a small sample size and how it can create a restricted range. These two examples also highlight the importance of assessing whether the data represent a limited range prior to performing either a Pearson's or Spearman's correlation. This concludes the video on restricted range.